Okay. I hope you can hear me, which I think you do. So we're going to do example 2, and I'm going to work out from the same element. Okay, so we're going to do example 2. So for example number 2, I'm still going to use the same element down here. Okay, and hopefully I can use the same Mohr circle also to not waste your time. Okay, so I'm going to wipe this out. Okay, so based on the same element now, right? What if now we want to find the stress state on the plane that is rotated? Okay, so we're going to put a certain okay. So this is 30 degrees. Okay. So the question asks, or for this second example, we want to find the stress state of the element when it is rotated or rotate. Yeah, always rotate 30 degrees clockwise. Sorry, anti-clockwise or counterclockwise from the horizontal axis. Okay, so this is exactly. So we want to find the stress state. So now we're going to call this stress state over here. This is our Y30. Okay, that's our Y30. So we can still use the same Mohr circle. So I'm going to copy our Mohr circle. Everything's still the same. Okay, so still the same. I just need to align the axis properly. Okay, so we still have to construct this Mohr circle. Okay, now watch this. Okay, now I want you all to pay attention now. So from here, okay, Y to Y30 on the element is what? 30 degrees. Okay, on Mohr circle will be what? 60 degrees. Okay, from point Y, not from the horizontal axis. Okay, from point Y over here. Okay, so from point Y, it has to rotate 60 degrees. Okay, it has to rotate 60 degrees. So this is the point that we want to find now. Okay, so it's rotated 60 degrees. Okay, so this will be your Y30 now. Okay, anti-clockwise, right? So from here to here now is 60 degrees. Okay, I'm going to change this. It's 60 degrees. Right, so this angle over here is 6. From Y, yeah? It's not from the horizontal axis. A lot of time students got it wrong. They thought it's from the horizontal axis. No, it's from point Y. Okay. So when that's the case, we now have to find what is our stress Y30 and our shear Y30. Okay. So with this, we need to find what is our beta angle. I'm going to call this angle over here beta. Right. That is our beta angle. Okay. So now we are going to find. We're going to find what is our Y30 and our shear stress Y30. Okay, that's what we want to find now. Okay. So before we do that, we have to find our beta angle. So beta is equal to 60 minus by the 2 theta p we had before. It is 21.8 degrees. Okay, so 21.8 degrees. Okay. So beta is equal to 60 minus 31, 38.2 degrees. Okay, so 60 minus 31.8, 38.2. So my advice is always find your shear Y30 first. Okay, and later you'll see why. Okay, so the radius we found out previously is 53.852. Okay, so it's 53.852, right? And then it is going to be sine, right? Sine by 38.2. Right. So what we are trying to find is we are trying to find this distance, this height now. It's easier because it's starting from 0, right? 0 shear line. So this over here, right? So we know the radius. We're aware that the radius is 53.852, right? And then I'll write better. I do apologize. So 53.852 sine the beta angle is 38.2. Okay. So something happened. Okay. Hold on. 53 sine 38.2. Right. So that's the height. So this will be equal to 53.852 times by sine 38.2. So it's 33.3. 33.303 megapascal. Let me do it again. So 53.852 times by sine 38.2, 33.303. Yes. Okay. Now to find stress Y30 is the calculation is a bit further, a bit longer. You have to take from your stress average, which is 10. Okay. And because Y30 is going towards the left, right? Right, going towards the left. So that distance is minus, right, 53.852 cosine 38.2. It cannot be sine because you use sine already. That's why I do shear first, okay? So this distance from, we know that the distance from here to here, okay? So this is a bit tricky now. So we know that the distance from here to here, right? This distance over here, this is equal to your 53.852, right? Cosine 38.2. But everything is relative to 0, right? So the distance from here to here, right? You have to compensate for your 10, right? So 10 minus by 53, 10 minus by 53.852 sine 38.2. Sorry, cosine. What am I doing? Come on. Cosine 38.2. Okay. So this will be equal to 53.852 times by cos 38.2. 10 minus, so it's equal to minus 32.320 megapascal. Okay, 33. Yeah. So let me do it again. So 10 minus 53.852 times by cos 38.2. Yep, 33.20. Okay. So when that's the case, you can also find your over here directly opposite. I will call it your x30. Okay. So stress x30, okay, is equal to, now because it's right hand side of your center of the circle, so it's 10 plus by 53.852 cos 38.2. So this is equal to, so 53.852 times by cos 38.2 plus by 10 is 452.320. Okay, so let me do it again. 53.852 times by cos 38.2 plus 10, 52.3. Okay, that's correct. Okay, right. So now we have to bring it back to the element. Okay, we have to. So now what's the difference between this and what we have done previously is that we have to consider the shear now. Okay, previously it's the principal plane. We don't have a shear. Now we do have a shear. Okay. Right. So we're going to draw the element now. So the element is rotated 30 degrees. Okay. So we're going to construct the element. So the original line. So this is our original. Okay. So this is our X. And then this is our Y. So this is X. So this is our Y. It's going to rotate 30 degrees anti-clockwise. Because we are doing the element now, right? Okay. So that is your 30 degrees. Right. So this is your 30 degrees anti-clockwise. So I'm going to rotate. Okay. So that's the axis, or that's the inclination of the element that we want to find. Okay. 30 degrees. Okay. So now we're going to draw. We're going to draw the element. Okay. So we're going to draw the element. Okay, we're going to construct the element.